we're Group 3, and our project is a solar absorption chiller. My name is Miguel Williams, this is Adrian Gonzalez, Robert Martin, and Juan Aristotle. So our solar absorption chiller is going to compose of different components and technologies. We're going to use a portable, self-contained, solar-powered, chill water, package, AC, absorption chiller. It's going to use solar heat, Stirling engine technology, and PV panels.
Okay, our proposed design is of a solar absorption chiller, like you said. The system is intended to be entirely self-contained and self-powered. Considering our target market and global needs, we want to make it mobile and packaged. That way all the entire system and all the components are within the same vessel and mobile, so it's easier to transport between locations. It's also easy to set up and break down. Our system is entirely powered by renewable energy. Our design, we're using a solar, an absorption chiller. We're using hot water to supply the heat to the absorption chiller, which is considered water-fired. We also want to recover the waste heat from the condenser water and recycle that back into the system. We're using the absorption chiller because of its low COP and eliminating the need for electrical power like the standard vapor compression chiller. The hot water is also going to supply heat to the Stirling engine, which also uses heat to run. Our solar energy we're going to collect using evacuated tubes and heat the water up to 300 degrees, at least 300 degrees, or maximum 300 degrees. PV panels can also convert solar energy into electricity, which we can use to power the controls, the pumps for the chiller, but also if we need to, we can convert it into electricity to generate or the solar heat for the hot water and the electricity.
Global impact. Number one is that the system will have no harmful emissions. It's not going to use any gas-based refrigerants that would escape into the atmosphere. Completely renewable energy source using solar, and maybe in the future be able to convert that into other types of heat collection. The materials are all recyclable. It's all ferrous materials or copper or standard off-the-shelf type materials. The refrigerant itself that we're using is a lithium bromide water solution, so it's not toxic. It's actually used to treat human animals. Globalization, this is going to be used, the idea is all over the world. Specifically, our target market is military or World Health Organization, Sub-Saharan Africa, Middle East, South America, places where electricity and fossil fuels are very expensive. So our target is to be able to give aid to those corporations. We researched different companies that make the absorption chillers, that make the thermal heat absorption panels, as well as the Stirling engines. There's a number of patents that we've looked into. Rover in the U.S., Kushan Chang in China. All of these have individual patents for different components, but nobody has put it together in a portable packaged system that can be provided to these organizations and put into use out there, whether it's a field hospital or military installation.
So in terms of the timeline, we're planning on spending 29 weeks to complete this project. And we have different tasks that we subdivide them in 3 groups. So we have the group task, the solo task, and the cooperative task. What they mean is that the group task is that we all are going to be working on those parts, such as the problem formulation, the survey, and all that. And then the solo tasks are individual tasks that each of us has to do. And the cooperative tasks are tasks that we have to have at least 2 members of the group to working on. In terms of the budget, we are the labor costs were, in those 29 weeks, we are planning to spend 696 hours at a price of $41 and $31 per hour. So that's going to be $28,000. And this is our prototype cost for analyzing the results that we did. In here, you can see that we are using the absorbing chiller. It's going to be $500. Solar located tubes, around $1,000, and so on. You have any questions?
have kind of an order problem. I think you did 4 reviews on 4 slides, all saying the same thing at the beginning. Like if you go to back to the very beginning, all the way back.
We'll just take from here.
Yeah. So the second slide, solar absorption chiller. Third slide, you had all of these keywords, right? Fourth slide, you go over those keywords kind of again. Fifth slide, you go over those keywords again, right? So it might be worth just going over those in detail one time. Just step through them kind of slowly and say, I mean, you only have 10 minutes, so do the review at the beginning and then go over that stuff again. That's, you know, it becomes half the presentation, right?
I only have 5 minutes.
Oh, 5 minutes. So yeah, so definitely. You only need it once, right? The other thing is the order. So then after that, you start going back into why this is important. It would be good to say why it's important first. So we want to design a solar chiller first because it's subject matter, chiller, whatever, you know, something like that. And then just in general, show us what a solar powered chiller is. I mean, from this, you said we're going to make a solar powered chiller, but I show the process, right? So how are you going to heat water using solar power? And then how is that going to be used as a chiller? You have some nice diagrams there. So show in that diagram and just walk us through the process. Okay, this is what we're going to do. The timeline, really quick. You should definitely say where you are now. I know you say kind of percent complete there on the side, but I don't know what week we're on at the moment. So it might be worth just putting a line.
Okay.
And then if you have things like 100%, so project summary is 100% complete and stuff like that. Just take a look at that and kind of go through that. All right. And then, so you're going to make the device?
We're going to do a prototype.
Okay. And you're going to spend $5,500?
No, okay, the absorption chiller exists. We bought a little mini refrigerator, which is uses the tiny absorption chiller.
Okay.
We're applying the solar water heating to the absorption chiller to supply the heat to it.
So it might be worth just, again, outlining what you have, what you're going to contribute to that so that we know what your specific abilities are.
Yeah, because we looked at, there's 3 different sizes. You know, we looked at a large, ideally we'd like to go with the large 20-ton unit.
Okay.
But obviously that's a lot of,
Yeah, right.
a lot of money.
The other idea there is if you're trying to bring it to Africa, right? If you're trying to get it over there, you might want it as portable and mobile as possible.
That's why
Right.
Yeah.
But it's
Right.
takes time.
No, of course, yeah. Yeah.
We have, we purchased the absorption chiller itself. We have talked to companies trying to get prototypes, but we have to, build it ourselves. The solar water heating, they have evacuated tubes available. It's just a matter of applying that to it and also figuring out if we're going to supply enough heat to power the unit. The PV panels, we plan on using pumps and stuff. We want to use the Stirling engine, which Mikhail is very familiar with.
Okay.
And that uses heat also, but can we use that to supply the pumps, or do we need solar powers?
And then just in general for the long term, it would certainly help to have some predictions associated with this. So a lot of these components are all pretty standard components. So talk about efficiency, talk about input and output, and maybe try to measure some of that in the very okay. But that, of course, you don't have.
We have predictions. We didn't write anything about that.
I would definitely, if you have them, that's great. So say, we think it's going to be 30% efficient or whatever, whatever you think it would be. The other one, just really quick, is the recycled materials. Just why don't you say what the materials are? Just kind of say them, so that way there's no ambiguity there.
Okay.
Ben took it over.
Sorry.
Thank you.
Thank you.